jump in, and then I'll pick up the beat, I'll clean up the mess as we go along. So what you got here is sort of a diagram that's kind of from the book, but not exactly. It's got what's called layers of necessity, right? Necessity are things that have to be true, okay? And it turns out that when you talk about things that are necessarily true, there's layers of it. It's not just one thing. So this innermost realm here, tautology is something that has to be true by virtue of its structure, meaning its connectives and nothing else. It doesn't depend upon the predicate or the sentences or anything else. It's just the connectives and nothing else. If that's true, then it's what's called a tautology. Remember, a tautology is when you do the truth table, the left side was all the pieces. Like you got two pieces, say the sentence is P and Q, right? The left side, P, Q, those are like two bets, right? On Philadelphia and what you guys used to Quebec, right? And you're laying out all possible scenarios of what could occur, right? One team wins, every team loses, one team wins, every team wins, blah, blah, blah. You're mapping the space of all possible outcomes. And a tautology corresponds to saying, if under the main connective it's true all the way down, no matter what happens in the world, whether one team wins or whether it loses, the sentence is configured such that it's got to be true no matter what. This is what's called a necessary truth. Kind of good? Good, kind of. Okay. So this is an easy example. For example, not A or A. A is either one. Any sentence A. A is any sentence. Any sentence A has got to be what or what? True or false. So either A is not true, meaning it's false, or A is true. That statement itself in our logical system, remember, if everything's true or false, we don't assume shades of gray. Other logics cover that, not ours, right? That statement itself, that every statement is either false or true, is itself true. So this will always be true. That's an example for tautology. Kind of with me. Okay, good? Next layer out, what's called FO validity, standing for first order validity. This is a bad choice of terminology by the book. They know this, but they did it anyway. Validity is actually a relation between sentences. They're applying it here just to one sentence, yeah? And the idea is, if this is true by virtue of the connectives and nothing else, this is saying connective plus quantifiers and nothing else. That's what makes it true, right? So it's basically, think of it as anything that's a tautology has automatically got to be these other things. But there are things in this tile here, this outer circle, that count as necessarily true, but aren't this. So that's why it sort of layers in necessity. Let me explain that. So here's an example. Not everything is P. If, that's the main connector. If not everything is P, then it follows that something is not P. Okay, so the idea here is this has to be true by virtue of the connectives and the quantifiers, nothing else, right? Let me use a concrete example to illustrate that. So I say, if it's true that not every, and I've used something like this before, but I'm going to use it again. We haven't actually gone into this in explicit detail. This is called quantifiers for De Morgan's. De Morgan's quantifiers equivalents. Not everyone in this class, imagine, right? So here we are in the class. I say, not everyone in this class is Asian, right? That's true. Why? Look around. Is everyone in this class Asian? No, so not everyone in this class is Asian. Why? Because? Forget that. That's actually not true. Look around.
It is true.
So why is it not true? Because there's someone, at least one person who is not Asian. Okay, let's make it easier. I went to school in Wisconsin. Anyone from Wisconsin? Okay, fine. Yeah, I know. You're from my undergraduate work. What do you think it's like over there? Racial makeup. No. Very Caucasian, right? So I go there, and I can be mistaken for anything, and they did.
Indian.
You're Indian? Yeah, sure. You're Mexican? Of course. Instead, it was like, you're Hawaiian. I'm like, yeah, I'm Hawaiian. You guys use shells for money? I'm like, yeah. I can't even say, no, Hawaiians are different. If I get into that conversation, they just look at me with this blank stare. Sure, I'm Hawaiian. I do hula. Lies are low. But it just imagine, it helps to imagine that, right? I say, not everyone in this class, look around, imagine the class. It's pretty much all Caucasian, right? And I say, not everyone in the class is Caucasian. Why? Because? There's at least someone, one person, yeah, who's not Caucasian. That's all you need. Even if they're half Caucasian mixed, it's still not fully Caucasian. You see what I'm saying? Okay, so that's the logic of this. In fact, it turns out that this is true not by virtue of your knowledge of being Caucasian or whatever else. It has to do with the structure of this. I could stick in anything I want. Not everyone loves logic. Why? Because some people don't like logic. You can use whatever you want. That structure remains true because the connectives plus quantifiers, nothing else. Kind of make sense? Now you move one layer out, and you have what's called logical truth. And it says, look, if this layer right here is connectives plus nothing else, that's what makes it true no matter what. Then this layer out says connectives plus quantifiers, nothing else. It makes it true no matter what. This layer out says connectives plus quantifiers plus predicates, basically the full meaning of the statement. If it's true no matter what, it's what's called a logical truth. This maps to, and remember from way back I said anaton, don't worry about that because I'll explain that later, right? I gave you this sort of loose explanation. I said, if you see, you highlight this other stuff and you see that that follows anaton, it's a rule that covers that, right? Its true explanation actually comes over here. So this is individual statements. But when you talk about relations between statements, you get the con rules. Tot con, what's called FO con, which we're going to cover today, and anacon. Anacon, its true explanation, says that if you take into account the meaning of the connectives plus the quantifiers plus the predicates, the full meaning, and you determine that something else has to follow, anacon, which is short for analytical consequence, is the rule that does that. Another term for this corresponds to this notion of logical truth, which applies to one sentence. Now we're talking about relations between sentences. Another term for anacon is logical consequence. When it applies to one sentence, logical truth. Or when it applies to more than one, anacon or logical consequence. Kind of with me? Okay, so let me, if you're not there at all, that's okay. Let me explain how this will work. So here's an example. If A is larger than something, then what follows that? Think about it. If you know that A, Albert, is larger than someone, then it must follow that someone is smaller than Albert, because that's logically contained within this, right? And that's the idea of logical truth. It's something that has to be true no matter what. These three layers are considered to be the essential most layers of truths. Anything that's a tautology automatically qualifies as true in all these other layers. But there are things that are FO validities that are not this. And also, there are things that are logical truths that are neither this nor this. So think of it as nested layers of necessity. Outside of that, what are called necessities, but they're restricted to the language you're using. For example, in our language, TW necessities, and you have a multitude of other kinds of languages that cover this. Like in mathematics, if you're doing calculus, you have calculus-related necessities. Things that, assuming the premises, this has to be true no matter what. If you took geometry, there are Euclidean necessities. Things that, if you assume those axioms, you can prove, using side, angle, side, and whatnot, these other kinds of congruencies, right? So as a whole, in fact, there's an infinite number of other languages where you've got these what are called other world necessities relative to the language you talked about. TW necessities include things like, here's an example, things that have to be true in the way we've set up our world, our language, right? So everything is up, tet, or q, or dodec. That's just the way we specified it, right? And that's always true, and that's one example. You can, in fact, expand that out. Anyone heard of, yeah, I have a question. Platonic spheres? Platonic solids?
Mm-hmm.
Oh, you have? Yeah, it's connected to all kinds of weird stuff. Like, interesting stuff and also weird stuff. It has a history on the one hand connected with logic, and then another history connected with metaphysics. You guys know the Rosicrucians and the Freemasons, that stuff? Yeah. Like Da Vinci Code and all that? Okay, this stuff gets transfigured later on into basically alchemic logic. And it gets used later on to talk about what's the underlying structure of the universe. So initially, there was thought, why in our language do we have these cubes and codex and whatnot? Is it just shapes and that's all it is? It's actually homage to Platonic times where they had these kinds of things. And these are the basic idea of our first precursors to the notion of atoms. You got these kinds of simulated like label blocks come together in different ways, and you get every known shape in the universe. And their theory was, yes, they needed some other shapes added to this, okay? Later on, the Platonic solids were the more complete set. Later on, they added to this and found that with these kinds of things, you can actually what's called tile the surface. You can take any surface out there using these basic shapes and put it together to form pretty much anything else. The one exception was something like a sphere, right? So you need to add that in there. Kind of make sense? So the idea was, if these components, just logical thinking, can actually cover any area whatsoever, you can use this to build tables, build spaces between, build chairs, to build in fact anything in the known universe. And this sometimes has a little underlying logic for how the universe itself is constructed. The logic is that's why they use this particular method. That's why we use it. No. It's more even. That was actually one of the things they used. Platonic solids were used to map the structure of the universe, planetary system. It wasn't correct, but they used it back then. Yeah. Kind of good? All right, let's move on. So these necessities are things that have to be true just in our world, but not in others. They're extensions of this language. The symbol used for this back in the day was this: things that are necessary. Yeah. Things that are outside of that sphere. What's the opposite of necessary? Not necessary, which means what? If it's not, doesn't have to be true. Then it. Not necessarily. No, it could be true, right? But it doesn't have to be true. Unneeded. Okay. So the idea is not necessary. The correlate of that is possible. This diamond symbol. It could be true, but doesn't have to be. Things that are necessary have to be true. You're forced to, no matter what. Whereas things that are not necessary are sometimes more contingent or possible. They could be true. They don't have to be. What's called modal logic studies this in much greater detail. I'll give you an application a bit later when we get to this. Okay. We good? All right. All right. So let's get to this true functional algorithm. That's the first thing, and I'll explain what it does. I'll just give you an example and then explain what it does. The idea is you underline the scope of the parent. So take this sentence as an example, right? If I had given you this in the midterm, suppose I was a real jackass and I said, I'm going to give you this in the midterm. You guys look at that and say, what in the world is that? I've never seen that. I've seen this and I've seen that, but what is all this other stuff? You don't recognize it, right? So the true functional algorithm says, in order to look at the structure of the sentence in terms of its connectives and nothing else, not including quantifiers, underline the scope of the parents. So this parent goes from there to there, right? Just chunk that thing and call it A. And then this one goes from there all the way through. It absorbs the knot. You just chunk that whole thing and call it B. Because if you cut and paste that upon that, they're not the same, right? It's called different things. So the underlying true functional form, that's what the true functional algorithm does. What's the true functional form? Is not A arrow B. Basically not blah arrow blah, right? Kind of with me. Okay, now the question is this sentence, not A arrow B, is it a tautology? Well, you guys know how to do that. You take the sentence, you list the pieces, and you can do the whole thing, but let's use it, just use common sense. This says if not A, then B. Does A have any relation to B? Necessarily no, right? So do you think this is going to be true all the way down no matter what? No, so you can do it and fill it out, but you can think theoretically already, you know it's not going to be true. So this is not a tautology. Make sense? So the form of this sentence indicates that it is not a tautology. But the question is, might it be something else that's true? I use the same example here. Not everyone in this class is Caucasian. If that's true, then that means someone is not Caucasian. Make sense? So it's true in a different sense. That's what's called ethyl validity. So there are things, again, that are true in this outer tire, like this sentence, but they don't qualify as tautologies because of their form. That make sense? So what this is getting at, this layers of necessity, is actually layers of form. That's what logic is about. Layer form upon form upon form. These are commonly used. There's many examples. Suppose someone presents you with an argument. In fact, suppose it's in a legal context. And they give you all this stuff and it's written down. It's like in a contract form. You're like, I can't think of this. It's like a tax form. It's just all real complex. That's one major, that's the full content. But the idea is, using logic, you can abstract from this, not just legal documents, pretty much everything, and look upon layers of form. Okay, so you break this down, you say, okay, section 1 is stating the claims, whatever, where the person who's suing, let's say, they're making a certain claim, and here's what the claim is. Step 2 is, section 2 is saying, here's the concrete instance of the claim, and it's citing other law to support the case, blah, blah, blah. So it's like you say, okay, that's the structure of it, and now you can look within each of these sections and find further arguments and sub-arguments. So the idea of form upon form upon form is can you discern, can you ignore the things that don't matter for the moment, see its overall structure, and then once you get that down, you can then break down each of the substructures into further structures, and you get a sense of how the overall thing comes together. That makes sense? So that's what logic is trying to do. It's not all this stuff with proofs and whatnot. It's really exercises and forms. And once you get that, you start recognizing these forms elsewhere, all over the place. How to structure thinking, how to structure your thoughts, how other thoughts are structured or not, seeing gaps within them and so forth. Kind of makes sense. Let's move on. So this is not a tautology, but it qualifies as a first order and ethyl validity. And our first exercise, open up your books to page, whatever it is, 266, 10.1. That stuff we just copied down here, right? So we're gonna apply the true functional algorithm here to get at these layers of necessity. Okay? As we go through it, I'll give you some philosophical examples. Going back to that modal logic stuff, but some others as well. So let's try it out. Everyone, I assume you wrote this down. Remember, we're turning this in. The homework today is all written. You're turning this in at the end of class, and then we're done. Nothing to turn it online. So woohoo! It's a like 3 2 points. Good? So make sure you copy this down, put your name on the top. If you don't put your name on the top, how are you going to get the 2 points? Alright, so let's do the first one. You have to classify each of these according to 3 options. 1, it's a tautology, or 2, it's a logical truth. This thing out here, but not a tautology, they're leaving out ethyl validity for the moment. Forget that, okay? So it's either A, a tautology, B, a logical truth, or C, outside of all this, not a logical truth, meaning it's a contingent truth. It could be true, but it doesn't have to be. Let's just try it out and get a sense of it. So the first one, here's the sentence. So what you apply to all of these from the get-go is this true functional algorithm. Let's do this together. So here's the parent. How far does it go? All the way through. So what do you call this thing? Just give it a capital letter representation. A, sure, A. Now the question is, copy all this down. This is what you're trying to do, okay? The question is the sentence A a tautology? No, because if I did it like this, what am I passing this for A? True, false. There's no connected here, right? So true, false. Is it true all the way down? No, so it's a tautology? No, so this thing doesn't have the right form for being a tautology. But still the question remains, is it true in some sense? So now, the idea, second step is you remove this in your mind, the underlining, and now you look at the full meaning. Remember, logical truth is you take into account the connectives, plus the quantifiers, plus the predicates, meaning basically the full meaning of the sentence. If you determine by in terms of its full meaning, it has to be true no matter what. It counts as what's called a logical truth. These are sometimes called metaphysical truths. Metaphysics, I mentioned before, in philosophy, not crystals and white line and whatnot. It's sort of like getting at big topics that exceed what the sciences get at, that may not have anything to do with humanity. I mentioned that before. Really stage. Okay, so let me just use this as an example after we cover it. So what does this say? For each object,